Hello. So let's go for the final step of this optimization. So what we have done, we just decided to answer to add this submit answer. Although asynchronous, we see that it has a high penalty, and the latency is very high with 200 students. When you, of course, there are a lot of invocations, 4,000 invocations, but by the 200 students. But although it's a lot, and we were a bit asking ourselves why that, and and that's this service. So this is the submit answer. We go there and we basically do this insert. Why that? So what we have decided to do, we just commented this code and we run the test. So we say, well, it's not going to do anything, basically, and it's going to just invoke, the front end invokes the client, the back end, and there's basically no insert at all. And we realized that it still spent a lot of time. So the difference was almost nothing. And then we decided to comment as well this line here. And amazingly, it was a lot of drop on this. So why? What is the problem? What was the problem? It was in the authorization. So when you look at the authorization, we look at this code and we realize something. And what you realize is that there's a many-to-many relationship between the user and the course execution. And every time you do a verification, basically we're going to see if the user is enrolled in this course execution. And as time goes by, there are more users and more course executions. And then you have a lot, you spend a lot of time doing this. And another thing is that you do it for every invocation. So every invocation of a service, you need to do the access control. So we need to optimize access control. And what have we done? So this is basically this, we start with this quiz access. And what we have done, the first thing, we go here and we find what is the course execution ID, for instance, in this case, and you write a query to get the course execution ID. Okay, nothing special. But what was different now is in this user as this course execution. And in this code, we write this query, count user course execution pair by ID. And we try to check if it is equal to 1. So what happens here? This is not visible in the model, because in the model, a user has a list of course executions. And the course execution has a list of users. But there's a table there. And what you're going to do is basically just to do a query in this table. So what you want to do is basically to go to this table, users course executions, and try to see how many tuples there are there that we have the user ID and the course execution ID. It's the single query. Okay? And so this is optimized a lot. It's a single query and you get 0. If 0, no, is not enrolled or is not teaching. And if it's 1, yes, it is teaching. And you optimize other things. We optimized other queries, so we decided, well, let's optimize. And we very carefully will look at all these cases and optimize other queries. For instance, if a user has an execution of course, so this is used when, for instance, the teacher is creating a question, because the question is related with the course, not with the course execution. So we need to decide to check whether the user is teaching a course execution of that course. Well, and we have done here And another optimization that we have done is something like this, is using a entity graph. And what is an entity graph? We just check this user, but with a single query, we get the user and all the course executions of the user instead of. So that's a way that you generate this graph, you get the graph, and then you work with the graph. So that's another optimization. So we have done this type of optimizations, and then let's see what was the results after this optimization. Okay, and the results are amazing. When after you optimize this with the same data in the database, we moved, look, it's the same year, but we moved from 11 seconds to 898. This is in my machine, 898 milliseconds. From 7 seconds to 500 milliseconds. Okay? And these are these two services that we define that basically write just on tables, that are the logs and the conclusion that we decide to optimize. Even though we were able to reduce the impact on the other ones that access the domain model. So even in this case, we reduced from 15 seconds to 9 seconds. Okay, which means that in these 15 seconds, a lot of the cost was related with the authorization code. Okay, so what we have done finally, we just install the code in the real servers, and let's measure these in the real server and see what are the differences now in the real server. And in the server, we run it for 200 first. Okay, and if we have 200 students answering, okay, we got something like much better. Look, 4, because what is the difference here now? My machine is 2 cores and they have 4 core. So basic is the half. Now, every time a student selects in the background, selects an option, is 500 milliseconds. And when the student submits the quiz, 300 milliseconds instead of 400. And even the other ones reduced a lot, from 9 to 3, from 11 to 3. So I think that now we can perform these, can use the quiz tutor for a lot of people answering. And we have done another test, and we run it with 300. Okay, and the results, amazingly, what is amazing here is that, of course, they get worse when you have this service that access the domain, but look how it is, do not change when you have the ones that basically just write on the log tables that basically have no connections. So it's just they are just inserts. Low. And even these 500 milliseconds is a bit higher than the 400, but because of these overhead there, because if you reduce these over there, these will be even less. So it was a long journey, but I think that now we can trust the quiz tutor to answer to 300 students. Actually, I ran it to 500 as well in the server. Okay, and look, you have 1 second there, but the median is 500 seconds. Of course, it increases there. Okay, just probably a final note: how can you solve even this part? You can solve it in the procedure where you provide the quiz. For instance, if instead of asking the students to do the get quizzes get available quizzes. Instead of doing this, I just provide a quiz with a QR code. So if I provide it with QR code, basically there's no this overhead will not exist. Basically, there's no this call. There's only what? A start quiz. And even the start quiz, I can improve it with a functionality that the teacher can use that basically it generates the quiz answers for all the students, okay? So when the student starts, it already exists. So these can be even reduced. Okay, I hope we enjoyed this journey how to optimize the several or hundreds of students answering the quiz. Okay, and we can optimize it even more with microservices, but that's not something that I'm going to teach in this course. Okay, enjoy.